Alright, hello everyone. My name is Vivek and I am a software developer. I make videos about Kubernetes, containers, Go as a programming language, and software engineering in general. So in this particular video, we are going to look into these two Kubernetes resources named deployment and stateful sets, and what are the use cases where we should actually use these resources. In some of the previous videos, we have set up a basic understanding of what Kubernetes is and how we can leverage Kubernetes to run our containerized application. So if you have not checked them out, maybe you should. So we know that to run pods, or in other words, to run our containerized applications, we can use some resources, some Kubernetes resources, right? So for example, stateful sets or deployments. So these are the two main resources that we use to run our containerized workloads. But there is a lot of confusion around in which particular case we should use deployment, or in which particular case we should go with stateful sets, right? So let's just go ahead and try to understand that, right? So if we talk about stateless applications, or let's say if we just go to the Kubernetes documentation, it says that if you have to run stateless applications or single replica of stateful applications, in that particular case you can use deployments, right? But if you have to use multiple replicas of stateful applications, in that particular case we will have to use stateful sets. Now this makes a bit of sense, but we are going to look into it a much more detail. So what do we actually mean when we say let's say stateless applications or single instance of stateful application? So let's take a very simple example, right? So let's take an example of MySQL. So let's say this is the MySQL instance, right? And this MySQL instance needs a storage, right? So if we talk about MySQL database, we actually just refer it as a volume, or as a storage, right? But eventually it is MySQL application, the code base, the code, and the actual storage, right? So let's say we have these two things, right? MySQL and storage. So if you have to run single instance of or single replica of MySQL, you can use deployment very easily, right? Because let's say if this particular MySQL instance or MySQL pod is being managed by, let's say, deployment, right? In that particular case we won't be having any issue, because in deployment we can specify the PVC like we have seen in our previous examples, right? So in the manifest of deployment, we can specify the volume or persistent volume claim, right? And that persistent volume claim, let's say this is PVC, this persistent volume claim would be referred from the pod that would be created from this deployment, right? But the problem arises when we try to run multiple instances of stateful application using deployment, right? So for example, let's take an example of Mongo, right? So but before that, let's try to set up a basic understanding of what do we actually mean when we say multiple instances or multiple replicas of uh, a stateful application, right? So let's take an example of MongoDB, right? So let's say this is one instance of MongoDB, this is another instance, and this is another one. So let's say we want to run 3 instances of MongoDB application. What do we actually mean when we say distributed database or distributed Mongo installation? So in that particular case, what we actually mean is all these instances should refer to their own storage, right? So this particular Mongo instance should refer to its own volume, right? And this particular instance should refer to its own volume, and similarly the last one, right? So this is how this is very very loosely we can say that this is what we actually mean when we say running multiple replicas of a stateful application. So let's say we are running Mongo, 3 replicas of Mongo. All those replicas should point to separate storage, right? Apart from that, the other thing that I would like to emphasize is all these replicas should have a way to communicate with each other, right? Because to client, if a client wants to communicate with this particular MongoDB installation or MongoDB cluster, for client, this entire setup would be treated as single entity and they should reply as single entity, right? So to client, it should not feel like there are 3 replicas running, right? So they should somehow communicate with each other, all these replicas of Mongo. So let's say this is Mongo replica 1, right? And this is, let's say this is, sorry about that. So let's say this is Mongo replica 2 and let's say this is Mongo replica 3, right? So to client, it should feel like they are talking to just one database, but internally all these replicas of Mongo should be able to communicate between themselves and then they should reply to the client, right? So this is what we would like to achieve either using deployment or StatefulSet. Now first we will have to look into why we cannot do this using deployment, and then we can see how we can leverage StatefulSet to achieve the same thing. So let's just discuss or point out the issues that we want to address. First, all these instances should refer to their own storage, right? And the second, there should be a way in which these Mongo instances should communicate to each other, right? So for example, if this is leader instance or leader replica, this should be able to figure out what are all the other replicas that are there in the cluster. So these are all the things that should be achieved using a particular Kubernetes resource, either deployment or StatefulSet. So now let's just try to achieve this using deployment. So already I have already created this architecture, right? So in this particular example, we are, let's say, using deployment to achieve the same thing, right? So if we look into the manifest of deployment, we actually specify the PVC, right? So all these pods are going to point to same PVC, and if they are going to point to same PVC, in that particular case, eventually all these pods are referring to single storage, right? And we don't want that, because in the case of actual distributed storage, we would actually be we actually want to refer separate storage from separate instances as we have seen here, right? But in this particular example, if we are using deployment, since from deployment we specify a persistent volume claim, all these pods would be referring to this persistent volume claim, and eventually all these instances would be referring to the same PV, and hence we are not able to actually achieve the distributed nature of the database or of the application that we are running, right? The another example or the another way we can try to do this is, since in this particular example all these pods were deployed using deployment, they were referring to the same PVC. To overcome with that particular problem, what we can do is we can run, or we can try to run the pods separately or manually. So here we can see that pod is not being managed by deployment. So in the pods manifest, we can actually specify which particular PVC it should refer to, right? So in this particular case, we can see that, yeah, we can see that each instance is able to refer to a separate storage, right? And eventually they would be pointing to separate volume. So we are somehow able to achieve what we discussed about, right? Each instance should have its own storage, right? And that would be the true nature of distributed system. But problem here is we don't have any way using which this particular instance should connect or should communicate or can communicate to other instances or to other replicas of MongoDB installation, right? So to resolve this problem, what we can do is we can come up with this particular architecture, right? So we are running the Mongo instances using let's say deployment, right? And again, since we are running instances using separate deployments, right? So in separate deployments, we can specify separate persistent or different persistent volume claims, right? And that's why we can refer to separate or different PVCs. So eventually we can see here, these pods, all these pods are referring to different storage, right? So we are actually running distributed storage here, and to facilitate communication between these pods, what we have done is we have created service for each deployment, right? So now we actually, in this particular architecture, we are actually able to resolve the problems that we discussed earlier, right? So each instance has its own storage, right? And they are exposed by services so that they can communicate with each other. Now the problem with this particular architecture is, let's say if this particular pod is restarted, right? So this is going to have a separate identity or separate host name, right? In that case, it would have to register itself with a separate identity with the leader node, right? Because in a lot of cases, in a lot of systems, all the secondary replicas or all the secondary nodes have to register themselves with the leader node with their, let's say, IP or their identity, right? Because in this particular case, this replica is being run by deployment. What is going to happen is, if this particular pod is restarted, it is going to have a separate identity, and then it will have to register itself with the separate identity, right? And we don't want that, right? Because let's say if this pod was registered with the leader node with name A1, and again, if the exact same pod is going to be registered with the different name, that is going to be a problem for us, right? So that is the main reason this particular architecture is not going to work, right? Apart from that, the another problem is, let's say this is leader replica or leader node. How this leader node is going to figure out what are all the other secondary nodes or secondary Mongo replicas? We are talking about, let's say, Mongo database. What are all the other secondary Mongo replicas that are there or that are running in the cluster, right? So these are the two problems in this particular architecture. Now, to resolve all these problems, to overcome with all these problems, Kubernetes provides us with another resource, that is StatefulSet, right? So if you look into how StatefulSet helps us to resolve all those problems, in the case of StatefulSet, we can actually specify persistent volume claim template instead of persistent volume claim, right? So here in the case of deployment, we can see that we specify persistent volume claim, right? But in the case of StatefulSet, we can specify persistent volume claim template, right? And because of persistent volume claim template, all these pods that are going to be spinned up using this StatefulSet, all these pods are going to refer to separate or different PVCs, and eventually they would be pointing to different stories, right? So we are able to at least achieve the first thing, that was all the instances should be able to, or all the instances should be able to refer to separate or different stories. The other thing that we want to do using StatefulSet is creating a headless service, right? So we create this service in the case of StatefulSet, and using this particular service, what we can do is we can actually communicate to any pod that we want to, right? So if we have created a service with cluster IP set to none, that service is called headless service. We are again going to discuss about services in one of the future videos, let's say. But for now, let's say if we try to create a cluster IP type of service providing cluster IP none, in that particular case, that service would be called headless service. And using headless service, we can contact any pod that we want to. So for example, let's say this is the pod, right? So to contact or to try to talk to pod 0, what we can do is we can say pod 0 dot name of the headless service. Let's say the name of the headless service is HS, right? So pod0.hs dot namespace in which this particular thing is created. So let's say demo namespace. So pod0.hs dot demo dot svc dot cluster dot local. So if I show you the DNS, right? So this is how the DNS for pod0 is going to look like. Dot demo ns dot svc dot cluster dot local, and this is the demo name that we can use to contact to pod0, right? The another very important thing that StatefulSet helps us with is the ordinal naming of the pods. So as we can see in the case of pods, the name of the pod is some arbitrary string, right? But in the case of StatefulSet, this is how the pods are going to be named. So name of the StatefulSet hyphen ordinal index, and that starts from 0, and that helps us to that helps the pod to have stable network identity, right? If I just go ahead and try to talk about it more, if let's say somehow we restart this particular pod, right? If let's say because of certain region this is restarted, this pod is going to refer to same PVC, right? And if this pod is deleted, this PVC will not be deleted, because again, because we are running stateful application, right? A state is stored in this particular storage, and there are chances that if the pod comes up again, that pod is going to need the things or the data that is stored in this particular volume. So that is the reason when we delete the pod, we don't actually, Kubernetes doesn't actually delete the PVC. PVC is kept as it is, and if the pod 0 comes up again, pod 0 is going to point to same PVC, right? So this is another thing that StatefulSet helps us with. And as we discussed, in the case of StatefulSet, pods are going to have definite network identity, so they are not going to change their names randomly. So yeah, these are all the things because of which we are able to run distributed database on Kubernetes using StatefulSet, right? So we are able to overcome or resolve every problem that we discussed about. For example, they are pointing to separate storage. They are able to figure out, they are able to talk to each other using this headless service as we discussed here. And we can use or any, let's say, leader node can use this headless service to figure out all the replicas that are there or that are registered, right, for this particular headless service. So for example, if I try to scale this to 4 replicas, right? So if I create another pod, name of this pod again is going to be pod 3, right? Because we are maintaining ordinal indices. And if let's say a node tries to figure out what are all the pods or what are all the Mongo replicas that are there in the cluster, we can use this headless service to do that, right? And we are going to look into that in a bit, right? So this is why we use stateful sets instead of deployments to run distributed databases or distributed stateful applications on Kubernetes. Now let's just go ahead and try to do this, try to look into this, how is this actually achieved, right? So let's create a namespace named Mongo test, and this is the namespace where we are actually going to install Mongo, and we would actually look how we can talk to, let's say, pod 0, or how we can figure out what are all the replicas of the pod that are running. So okay, I think I already tried to do that. So StatefulSet demo, right? And in this particular StatefulSet demo, I'm going to install Mongo application, right? So helm install. So it simply means that install MongoDB application on this particular namespace. Again, we are going to look into Helm in much more detail in future videos, let's say, but for now we can just assume that this command just installed Mongo application, right? And if I try to get all the pods from SSDemo namespace, we can see that here is an interesting thing. First of all, Mongo or stateful set tries, let's say we have specified two replicas, it tries to start MongoDB 0, right? And then once MongoDB 0 is up and running, it would try to start another replica, unlike deployment. In the case of deployment, if we try to run, let's say, 3 replicas of an application, all those 3 replicas are going to start at once, right? But in the case of stateful set, we can see that, yeah, we can see that once MongoDB 0 is up and running, we are getting MongoDB 1, right? So this is another very important thing that stateful set helps us with, because there are chances that in some cases first we want leader node to be started and then the worker nodes, right? And similarly, if we now scale down, this is the pod that is going to be deleted first, right? But in the case of deployment, we don't have any guarantee about that. So if I just try to show you, let's say if I try to run nginx, right, image nginx, and replicas is going to be 3, right, in the default namespace. And if I try to, not in the default namespace, let's say in the deployment demo namespace, right? So now that we have MongoDB up and running, we would actually look how can we figure out all the replicas that are running using the headless service, and we would also see how we can communicate to either of these replicas of Mongo, right? But let me just first show you, if we try to run, let's say, 3 replicas of nginx, right? All right, my bad. So get pods hyphen deployment demo, and we would be able to see that all the okay, so we are but we specified deployment demo here, right? Okay, never mind. Let's just create a new namespace, test, and run nginx in test namespace with image nginx and replicas 3, right? And I'm going to watch all the pods from test namespace. So test and watch, right? Okay, so nginx has been created. And now we should be able to see all these 3 replicas coming up at once, unlike stateful set, right? Okay, it's a bit strange. So we are running deployment in test namespace, okay, so deployment is created, but it's not up. Actually, it looks like we have something wrong with the minikube. Yeah, so API server seems to be errored. So what I would do is I would just restart minikube, right? And then we would continue with this. Okay, so what I have done is I have just restarted Minikube, and what I was trying to show you is we saw that in the case of StatefulSet, first we got MongoDB 0 up and running, then then Kubernetes tried to start MongoDB 1, right? But in the case of deployment, all the if we specify, let's say, three replicas, all the three replicas are going to get started at once. And if we try to look into that, let's say if we create nginx namespace, and in nginx namespace, if we try to run a deployment with, let's say, image nginx and replicas to be 3, right? And if we watch into all the pods from nginx namespace, we would be able to see all the pods getting started at once. Okay, so we did not specify namespace here, so let's just see from default namespace. So here we can see that all the pods are being started at once, right? But in the case of StatefulSet, Kubernetes first started first pod, that is ordinal 0 and 1, right? So this is another difference between StatefulSet and deployment, right? And similarly, if we try to scale down the things, this is the pod that is going to be deleted one first, right? So yeah, I mean, now that we have seen the difference between StatefulSet and deployment, let's just go ahead and try to achieve the things that we discussed about. For example, we would like to access this pod using headless service, and we would also try to figure out what are all the replicas that are running as part of Mongo cluster, right? So to do that, we will have to run a pod, right? And in that pod we will have to install some network utilities. So let's just run nginx, right? In the default namespace, let's say, with image nginx, and yeah, that's it, I think. And in that pod, we are going to exec into that pod. So what we have done is we have actually created another, let's say, another pod in the default namespace, and from this particular pod we are actually going to let's say access this pod 0, and we would do other things that we discussed about, right? So right now we are inside this particular pod in default namespace. So let's just try to maybe curl. Yeah, we do have curl here. So if I curl using the DNS that we discussed about, so pod 0, right? So pod 0, this is the pod name, and if we list all these services from SS demo namespace, we see this is the headless service that we want to talk to, right? So .0, right, dot namespace, so namespace is ss-demo dot svc dot cluster dot local, right? So this simply means that, I mean, we are able to connect to that particular pod, but we are not getting anything, I mean, connection is not accepted on this particular port, but we are actually able to connect to that particular pod, right? Otherwise we would have gotten another issue, right? So now we can see that we are able to see that from this particular pod we are able to access this replica of Mongo using headless service, right? Now to figure out all the other replicas, for example, let's say if leader node would try to figure out all the other replicas that are there in the Mongo cluster, we would be looking at the network details for this particular service, right? And to do that, what I'm going to do is I'm going to install a service or an utility on this particular pod named dig. So using dig, we can actually try to figure out all the details about a particular particular domain, and in our case this is the domain would be this particular service, right? So I'm going to install DNS utils, and once DNS utils is installed, so what we are trying to do is we are trying to install DNS utils in this particular pod, and from this particular pod we would try to figure out what are all the replicas that are running in this particular cluster, in this particular Mongo cluster, right? And apart from that, I would like to emphasize that everything or a lot of things that we discussed about here are from this book called Kubernetes in Action. So I would try to mention that book in the description. So if you want to have a look into that, you can do that as well. So now that we have dig installed, what we can do is dig SRV. We want to look into SRV records for this particular service, right? So service name dot namespace name, that is ss-demo dot svc dot cluster dot local, right? And if everything goes fine, we should be able to see. So we just ran dig, right? And we are able to see all the pods that are running in this particular Mongo cluster, right? And this is how leader node would be able to figure out all the replica nodes or all the secondary replicas that are running for that particular Mongo cluster, right? And yeah, so these are some things that can be used to run distributed databases on top of Kubernetes using stateful sets, right? So let me just go ahead and try to summarize the things that we discussed about, right? So first of all, if you want to run a distributed database, each instance should have its own storage, and they should be able to communicate with each other to figure out, or they should be able to figure out what are all the other replicas that are running in the cluster. And if we talk about some of the architecture, we would not be able to achieve that using this particular model, because all these instances are going to point to same PVC. So this isn't actually distributed storage. In this particular case, we are pointing to separate volumes, but these pods are not managed by any controller, for example deployment. So if this goes down, we would not be able to recreate it. We will have to manually do something, right? In this particular case, again, even if we have each instance associated with their own PVCs and exposed that with services, we will not be able to actually, the replicas will not be able to self-register them once they are restarted, because their network identity or their host name would be changed, their IP would be changed, right? This is the actual working flow that would be used, right? Because in this case, we can use persistent volume claim template, and using that, all these pods are going to refer to different PVCs, right? And eventually to different volumes. So there we would be able to achieve the one thing that we discussed about, that volumes should be able to refer to their, or instances should be able to refer to their own volumes. And we can use headless service, right, to figure out the, or to communicate to the every replica of the Mongo cluster, or to figure out what are all the replicas that are running there in the cluster. And another benefit that we have is the pods that are run using StatefulSet. Even if they are restarted, they get the same network identity, right? So if pod 0 gets restarted or deleted, the new pod that would be created would point to the same PVC and would have same network identity, right? So yeah, and another thing that we looked into is they are restarted in sequence and they are deleted in sequence, because let's say in some scenarios, if you have to run leader node first, then other nodes, so in the stateful set takes care of that. First we would be getting, let's say we got 0th pod, then first pod, and things like that. So yeah, I think this was pretty much it. again, the other thing that I would like to discuss about is deletion of the pods. So for example, if I try to delete, if I try to scale down the stateful set, this is the pod that would be deleted, right? And again, if I try to scale down the things a bit more, this pod would be deleted, but PVC would not be deleted. The reason is, if we are running the things using stateful set, Kubernetes knows that the application is stateful, so it should not delete the PVCs. And if I scale back this stateful application to 3, this pod would be created, and this pod is going to refer to the same PVC that it left, right? So yeah, I mean, this is about deletion of the pods. Now the other thing that we should look into is, let's say, if what happens if a node, let's say, node is not able to post its status to the Kube API server. In other words, let's say how stateful set handles pod deletion, right? Because stateful set has to be very sure that this pod is no more before creating the another pod, right? Because since, let's say, somehow stateful set thought that we don't have pod 2 anymore, and if it tries to create, let's say, pod 2 once again, since these pods are same, right? They have same network identity, they may run on same port, this is going to be a conflict, right? Because stateful set was not very sure that pod 2 is deleted and it spinned up another pod. So in that particular case, stateful set has to be very certain that it no longer has the pod before it actually creates it. And there are some ways to handle this, but yeah, I mean, maybe we can discuss about that in some other videos. So this was pretty much about what I wanted to discuss about stateful sets and deployments. Again, I would like to highlight that all these things are from this book called Kubernetes in Action. So if you want to get more detail about that, maybe you should check that out. This again, if you liked this video, you can consider subscribing. If you think this is going to be helpful for your classmates, colleagues, maybe share it with them. And that was pretty much it. I'll see you in the next one.